Corporate finance practice problem using OneNote. Future value calculation compounded quarterly. Get ready, it's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're in the tab on the left-hand side. We're in the practice problems area, and then down here in the 935 future value compounded quarterly tab. Also note that when using OneNote, you might want to take a look at the Immersive Reader tool. Many of our presentations will have a related file down here in the text areas, those being transcripts of the presentations, transcripts that can then be translated to multiple different languages and then listened to or read in multiple different language, thereby being a good complement to the presentation tabs up top. Closing this back out, we're going to have our information up top. We'll enter that information into the blue area down below. We're going to be looking at a future value calculation. The difference here being that we have the compounded quarterly as opposed to annually, and therefore need to be careful about the years that we're going to be using as well as the percent that we'll use. We'll take a look at this with regards to a mathematical formula. We'll take a look at it with regards to a running balance type of scenario or situation calculation. And then we'll take a look at it with an Excel, how we might put this into Excel, and then the tables on down below. Starting with our formula, the formula is going to be the future value equals the present value times 1 plus r to the n. So we're looking for the future value of the 150 investment, 5 years at the 16%. And we'll start that down here, but we got to recognize, of course, that it's going to be compounded quarterly. That's going to be the tricky scenario. So we're going to break this down into our format in terms of a table, and we're going to be having the PV times this whole thing in the outer column. Then we'll break out the 1 plus r to the n in the inter columns. So we have the present value of the 150. So we start off with the present value of the 150. That would not change whether we have compounded quarterly or other kind of compounding areas. Then we have the 1 plus r to the n that we're going to calculate. So we have 1 plus r. This is where things get a little bit different because the percentage up here is 16%, and we're doing this quarterly. So note that normally when you hear percentages, they will be in terms of yearly percentages, and therefore we're going to have to break them down to the period that will be covered for us. In other words, the percent that we use needs to be matching the period that we're going to use. In this case, we're using the period of quarterly periods, every 3-month type of periods, and therefore would need to take that percent and divide it by 4. So we would take that 16%, 0.16, divided by 4, and that would give us our 4%. So then if we take the 1 plus the 4%, and I'm going to add that to 1, that's going to give us 1.04 or 104%. And then we're going to take that to the number of periods, the next area where some complications will arise because we were given the periods in terms of years, but we are talking about periods in terms of our calculation compounding quarterly, every 3-month type of periods, every quarter of a year. Therefore, we're going to take our years times 4, and we're talking about 20 periods that are not yearly long, but quarterly long. So we have the 20, so now we got the 104 to the power of 20. I'm going to pull out the scientific calculator here to do that in Windows. To do that, we're going to go to this tab on the left, scientific calculator. I'm going to say this is the 1.04, then to the power of caret 20. That's going to give us about this 2.191123 and so on. This has been represented in a percentage format over here. And then if we take that amount, now we have this times this and multiply it times, we're going to say times the 150,000, we get the 328,668.47 about, which is here 328,667.47 about. So now let's take a look at it again. This time let's do it like a running balance type of calculation. This is something that would be tedious to do if you didn't have a spreadsheet, but with a spreadsheet, not difficult to do. So we'll do our running balance. How would that change? We're going to start at period 0 where we have our 150,000. Then we'll say in period 1, we'll multiply this out. Now, when we multiply this out and add the interest, we've got 150,000. And the first period is going to be times, we could do it this way, 0.16 for a yearly percent. That would give us the 24,000 if it were for a year. But it's quarterly, so I can take that yearly rate or amount divided by 4, and that would give us our 6,000. That, to me, is the most intuitive way to do it when you're doing a calculation and trying to get the percent for a particular time. When you use formulas, however, oftentimes you'll just change the order of that calculation. You'll be thinking about the percent with regards to the period that is covered. In other words, 0.16 divided by 4 would give us the percent per quarter, 0.04. Note that typically when you're given the percentages, they give the percentages per year, because when you give the percent per year, you have a fairly large number. When you break down the percentages per quarter or per month or per day, you're going to get to some fairly small numbers. Therefore, we have the custom of providing it per year most of the time. If you need to break it down to some other period, then you can break it down to some other period in this format. Also note that, of course, in using Excel, that's not difficult to do, because the Excel worksheet will then pick up those small numbers and calculate them even if they don't show those small numbers. Whereas when you're doing this by hand, it becomes more tedious to use basically those small numbers for the calculations. So if I take that 0.04 and I multiply it times the 150,000, we would get the 6,000 once again. If we take that 6,000 and add it to the 150,000, then we're now at the 156,000. If I go one more period out, now we're talking another quarter, so that we got another like 3-month type of period out. We're going to take that amount. I'm going to multiply it times the 0.16, the yearly rate again. That's going to give us the 24,960, which would be for a year. Take that, then divide it by 4. We get the 6240. That 6240 plus the 156,000 would give us the 162,240. And we can continue on with this on down. Note that it would be more tedious to do this by hand, but if you have Excel, this would be easier to do. It's going to be a longer table than we would have if it was for years here, compounded yearly, because there are 5 years. There would be 5 compoundings there. Now we have quarterly, so it's a much longer type of table, but it does give us a good idea of how the interest will grow on that basis. And if you have Excel, it's not difficult to do a calculation such as that, because you could use the autofill feature or copying and pasting to do so. Let's go to the future value down near, let's do this future value calculation within Excel. So this would be an Excel formula. How would the Excel formula differ if it was compounded yearly versus quarterly? So we'd have the future value kind of calculation, and then we've got the B4, which is going to be the rate. So that rate then that we put in place, when you enter this into like an Excel formula, you got to make sure that you're matching up the rate to the periods, the same rate per period. So I'm going to take that rate and we would divide it by 4, and that would give us the rate per period. Note once again that using Excel, I don't need to actually know what that rate is or type it in, because Excel will then calculate the rate out infinitum to what the actual rate is, even if it's multiple decimal points, even though I'm basically calculating it on the yearly rate. So Excel can work with those small numbers well, in other words, without having to do the rounding that we would have to do with a calculator quite easily. And then comma, we have the number of periods. We have 5 years. They gave us the periods in years, but we're compounding quarterly. Therefore, we took that number of periods times 4 to give us the full amount. And then comma, comma, we then have the present value. That's going to be the 150, which will once again give us that 328,664.47. Also note that you want to be careful when people discuss different compounding like yearly versus quarterly versus monthly, because note what we did here when we're compounding quarterly. I took this yearly rate and we broke it down to a quarterly rate, and we took the years, of course, and broke them down to the number of periods on a quarterly basis. If someone was to take this same information and say we're gonna go from a yearly compounding and quarterly compounding, and they didn't change the rate, meaning they gave this same rate that would be the yearly rate as the same rate that we would use for a quarterly rate, we would have a drastically different result. And we will do some comparisons with annual versus compounding quarterly versus compounding I believe monthly in a future presentation, so you can kind of compare and contrast those. Just note again that when you change from going from compounding yearly to monthly or to quarterly, that how are you going to be representing this percentage? Are you using the same percent as if it's the same yearly percent, then use the same rate for the quarterly percent, or are you breaking this percentage down to the relative time periods in your comparisons. In any case, we'll take a look at that later. If we do this with the table time, we have to be careful with the tables as well, because these tables down here do not represent yearly or any particular periods. They just represent periods of compounding and the related interest rates. So up here we have 5 and 16, but the periods that are going to be compounded is the 5 times 4 or 20, and then the 16 divided by 4 or the 4. So if we go down below, then I have to make sure I'm looking at 4 and 20. So I'm looking at 4 and 20, 4 and 20, and that's going to give us the 2.1911. There's the 2.1911, 150,000 times the 2.1911 gives us the 328,665, which is approximate to the 328,668 that we had up top. Also note that when you're looking at different kind of compounding options using a table, if you're doing like a book problem and you're restricted to the use of a table, the book problem will typically have to restrict the numbers that they're going to give you to some degree, because the tables you can see down here will typically be representing percentages for whole number percentages. Meaning if there's a decimal percent, it's typically not on the table and you will not be able to be as exact with the table usages. So if you're breaking a problem down, they're going to have to use some intervals that will divide out evenly. So that might, make the problems a little bit easier, make it a little bit more, you'll be able to expect what you're going to expect with the percentages if they're going to force you to use the tables. Also note that the years will be somewhat limited as well, because when you go from years to different time frames like quarters or months, then this number is going to get quite large, and the tables, as you can see, this one goes down to 50 periods. And when you're talking about months, those periods, you can go past 50 periods quite easily. So tables will, of course, limit the types of calculations that you can have, but many times book problems will utilize the tables to restrict people from using things like financial calculators.